Good evening, everyone. Thank you all for coming tonight. I think this is the sixth online .NET meetup we've put on so far. For those that don't know us, my name's Charlotte. My colleague Michael previously, and we've also got Ryan on the call as well. We work for IO Associates. We are a specialist tech recruitment company that are based in Bristol, but we do cover the whole of the UK. We organise technology meetups in London, Reading, Cheltenham, South Wales, and we also sponsored .NET Southwest. And if you want to find out any more about those meetups that we do put on, then they are all on our website or online, which is just at the bottom there. Just a bit of housekeeping. Can you keep yourselves on mute whilst Jon presents? We would like to do questions as we go through. So if you have got one, just pop it in the chat box or raise a hand and we can facilitate that. All right. Yeah, over to Jon.
Cool. So Jon, I'll mute everyone, and then you'll just have to mute yourself. Unmute yourself. That's all right. And then what I can do is I can whack the poll up now. There we go.
Okay, so I guess I can start talking while the poll is up there. So welcome, folks. My understanding is that there was a desire to hear about C# 8. I did say, oh, well, I haven't learnt about C# 9 yet. I should really do so at some point soon. And in fact, I'm hoping to install the preview tomorrow and start playing with it. But apparently lots of people still wanted to hear about C# 8. I'm reckoning this will probably be my last ever C# 8 talk. It feels like I've been talking about it forever, including at the inaugural Reading.net meetup as hosted by IO Associates. I'm going to share my screen now and see if I can get this right for change. So hopefully everyone can see the Visual Studio. We will spend almost all the time in Visual Studio, occasionally popping up a console if necessary, and I can bump up the font there a bit as well. Before I start, anyone wanting to follow along, if you haven't seen in chat, this is all on GitHub. I don't think I've got any local changes yet. I do change things as we go through the talk, and if I need to keep any of those changes, then I will then sort of propagate them up to GitHub. But by now, I've done this talk so many times, it probably won't need to change much. Okay, we'll talk for a bit to start with about nullable reference types, which is by far the biggest feature in C# 8. And it's also the hardest one and the weirdest one. So I've got a bunch of demos on that. And then I'll probably take a few-minute break just to let people unmute and discuss things for a few minutes at about 7:45, 7:50, and then after a few minutes of that, we'll dive into the remainder of the features, just because actually an hour and a half of me just talking without any break from that is really, well, painful. Okay, so nullable reference types. There are a few important things that I want you to take away from this talk in terms of the purpose and meaning of nullable reference types, and I will say them multiple times. I will almost certainly think of another one that I want to keep hammering on as I go through. As I say, I'm a bit out of practice on this talk, and sometimes I have some notes with me. This is off the cuff. The two biggest things are that the purpose of nullable reference types isn't, in my view, to prevent null reference exceptions. It's sort of sometimes described that way, and in fact, in my first demo, I will show, hey, we've got a nullable reference, null reference exception, and we can get rid of it using nullable reference types. But that's sort of, it's demoing the feature rather than the purpose of it. I view the purpose of this to be letting your code communicate more clearly, which is really, really important. So I don't know how many null reference exceptions you've seen in the last, say, month, but I would be slightly surprised if you'd see more than a handful, because after 20 years of doing C#, we're quite good at avoiding them most of the time. The trouble is, often that involves checking whether things are null when we're kind of fairly sure that it shouldn't be null, but we're not entirely sure. And I will say you're still not going to be entirely sure after this. But it just feels like there's far too much time spent reading the docs and maybe even browsing into the code and saying, oh, is this going to be null? And I think, well, it looks like it probably isn't, but I better do something just in case. And we get these null checks peppered around the place. And it's painful. It's far better if you can get your code to speak about the types more accurately to start with. So that's the first point. The second point is when you turn this feature on, and I'll explain how you do that in a bit, the meaning of your code changes massively, but the behavior of your code does not change at all. And that is a design goal. So you'll get a bunch of warnings, probably, but if you run the same code as you had before, you will not see a change in behavior. Obviously, if you've got warnings as errors, then you won't be able to compile until you've made changes to the code. But if you just keep those as warnings, the IL generated is the same apart from some attributes that are added, and we can have a look at those in a little bit. Let's dive into the feature though, and we start with code which is not using nullable reference types. I've got it enabled in the project. I'll go into that a little bit more when I've shown you something useful, but I've turned it off for this particular source file, and let's just have a look. We have a perfectly standard class. You may be slightly confused about what this constructor is doing, and this is always a sort of Easter egg of this talk. This is, in my view, a beautiful way of writing a kind of no-op constructor, no-op beyond copying parameters into properties. In theory, if you looked at this from a Roslyn perspective, this is a tuple literal, creating a value tuple with 3 strings in, and this is a tuple deconstruction to 3 properties. However, I use this syntax all over the place, far more than I use tuple literals for anything else, and it's really, really lovely. So it's just copying first name equals first name, last name equals last name, middle name equals middle name. And the compiler is actually smart enough to do that without creating the tuple and then calling deconstruct on it, or using item 1, etc. But it's just doing simple stuff. So the person class is really just a data transfer object with first name, last name, and middle name properties. Okay. In our main method, we're constructing 2 of these person objects, one for me. So I have a first name, a middle name, and a last name, and one for Miguel de Casa, who does not have a middle name, as far as I'm aware. If one day Miguel tells me that he does actually have a middle name, then I'll need to apologize significantly. Having constructed both of these, we call the print name lengths method twice, once passing in a reference to the person representing me, and once passing in the one representing Miguel. Now, the print name lengths method, I mean, this is really demo code as much as you'll ever see it. No one really wants to print the lengths of the first, last, and middle names of a person, but it shows the point. There is nothing to stop us from using interpolated string literals and an expression body method, other than it would make it harder to demonstrate the feature, simply because there'd be too much going on in one place. So just take this code as read, that we extract the first, last, and middle name from the person, and then we come up with the first dot length, last dot length, and middle dot length. Okay, so when I run this code, what is going to happen? I've just seen someone saying there is no sound. Okay, Callum said that they can hear fine, so RN Gorin, I'm afraid it's probably a problem at your end. So I'm going to run this code now, and it shouldn't surprise anyone that print name lengths with John will work and say first equals 3, last equals 5, middle equals 6. And then when we get to print name lengths Miguel, it will go bang in this statement, because when it tries to dereference middle and take middle.length, we'll get a null reference exception. So I'm just going to run this. I've got a little sort of demo framework here that just lets me choose which example I'm going to run. So this is basic demo number 2, and sure enough, we get null reference exception at line 36, which is this statement, just as expected. Okay, so far nothing new at all. This is all valid C#7 and would all behave exactly the same in C#7. We will do the magic of enabling nullable reference types just by not disabling it for this particular project. And now, unfortunately, the warning list is always kind of hard to zoom, but we have a warning of cannot convert null literal to non-nullable reference type. And the warning is under the null literal here. So we are passing in null as an argument to the person constructor for the argument that corresponds to the middle name parameter. So what's changed here? Well, because we're using nullable reference types, we have changed the meaning of these parameters and these properties. Previously, it was, well, they're string for the traditional meaning of string, which was it will be a reference to a string or null. With nullable reference types enabled, what we've really said is, no, this should be a string reference that isn't null. Okay. Now, the obvious question here is, well, why isn't the feature called non-nullable reference types? We've had nullable reference types forever. We've now got non-nullable reference types as a concept. The reason is we have syntax to make them nullable, which I will come to imminently. So these are meant to be non-null. These are meant to be non-null. We're trying to pass in null, and the compiler is aware that null is not a valid value here. So we have choices here. We could say, okay, well, we'll use empty string instead. At which point I can go and have a coffee, come back in half an hour, and then start presenting the rest of C#8. And that is a potential choice that you could make. You could say, okay, I want every person to have a middle name. Now, I should warn at this point, this is a terrible class, not just because of, it's assuming everyone has a middle name, but it assumes everyone has a first name and a last name as well. Names don't work like that. This is purely for demo purposes. But for the naive version of John who believes that this is a perfectly valid way of representing people's names, let's say, okay, well, we want there always to be a first name, always to be a last name, and sometimes to be a middle name. Let's say that it can be null. How do we make this parameter here, string middle name, nullable? And normally at this point, I would ask people how they would expect to happen, and pretty much every time I've asked this, everyone knows. We make that nullable by adding a question mark, just as we would for int to int question mark for nullable int. Now, the type of this is not nullable of string. Nullable reference types and nullable value types really are worlds apart. Okay, and I can't emphasize that too much. But this is now a nullable string, and our warning from this null has gone. It has moved to here. Okay. Why is that? Well, I'm trying to copy, and it's still, it's the same warning, converting null literal or possible null value to non-nullable type. Well, we're trying to assign it to the middle name property, which is still non-nullable. Okay, so now we need to make that nullable as well. Yay, the warning goes away. Oh, we've now got 2 warnings, here and here. Now, this wasn't just a demo of, and there's far more demo to come, don't worry. This isn't just a demo of how you go about things. It's a demo of what your real experience will be, that when you start introducing nullable reference types, you get warnings, you fix the warnings, and other warnings pop up elsewhere. It is playing whack-a-mole with warnings. Do not think you're doing anything wrong just because you get a load of warnings. That's absolutely fine. I have a blog post somewhere about my experience of doing this with Nodatime, which feels like many years ago. I think it may well have been about 4 years ago now, when the first C# 8 previews were around. And I started with 150 warnings, got rid of some, ended up with 200 warnings, got rid of a load of the rest. It bounced up and down. It's entirely reasonable to fix one warning and have multiple other ones. What you don't want to happen, which can happen if you're not careful, is you fix a warning by making one thing nullable, and that forces you to make something else non-nullable, and then you go back to revert your earlier change. You can end up ping-ponging between warnings, and that would usually suggest that something is inconsistent in your data model. Basically, your code is unsure whether it really should be nullable or not, where some part of the code is depending on it being non-null, and another part is depending on it being nullable. And that is usually the sign that you've got a bug. And that's a great thing to discover, because you're finding out about the bug at compile time instead of at execution time. Okay, let's go back to these warnings and see if we can fix them. Okay, so firstly, person.middle name is now a nullable string reference, fine, and I'm assigning it to a non-nullable local variable. We know how to fix this now. We're going to add a question mark in a minute, so that's a really simple one. But I want to highlight something else here, which is using middle.length also is generating a warning. Now, at first glance, that looks really strange, because middle is declared as non-nullable, and the same way as first and last. And first and last .length aren't complaining, so why is middle.length complaining? And what's happening is the compiler has an idea of whether something might or might not be null, which is slightly separate from the declared type of the variable. So just because I've said that this shouldn't be null, the compiler said, well, you might be assigning a null value to it, so I'm going to say it might be null. We'll come back to this. So when we add a question mark there, hooray! The first warning goes, and now we need to work out what we do here. So we could just use middle question mark .length. That is the null forgiving operator. Sorry, not null forgiving, the null safety referencing operator. And now the type of this expression, this is valid C#7, this middle question mark .length, and the type of that is int question mark. And if we run it again, we will see, sorry, it takes a while to build while I'm running Zoom. Zoom takes a fair amount of processor time, unfortunately, at least when I'm screen sharing. It's possible that if I presented this on a portable screen, it would be slightly better. But now, if we run it, we get first equals 6, last equals 8, and middle equals blank. Okay, so job done. We can go home, except, it's not terribly nice. We could print, 0 instead, or even dot to string, and then no middle name. That would work, I believe. Yes, but I think we can do better. So let's, and in particular, doing better allows me to show a different feature. So let's say if we do have a middle name, then we're going to print first, last and middle. Otherwise, we'll only print first and last. So for those of you who haven't seen it before, this is this or middle is object, and that works just as well for me. This is the preferred way of checking that something isn't null. It's not quite the same as that, because this code would, at least in general, it's possible that the compiler's optimized for string, but this, in theory, goes into the user-defined equality operator for string. It doesn't just do a null reference check, whereas this does a null reference check. The opposite of is object is null, and both of these are, or this at least is pattern matching. The first wasn't pattern matching. So this is just matching it against the constant pattern with null as the constant value. And this is the preferred way of doing that null check. As of C#9, I believe we'll be able to write is not null, which I can understand. You might be thinking, hang on, that's looking a bit like VB. But there are good reasons for wanting this. I've just noticed I've got questions, so I'm just going to put this back to is object so I know where I am when I come back, and let's read the questions. So, easy to find the blog on warnings. Oh, right, Steve's found it. Steve, could you post the URL to chat? That would be useful. Right, with the question mark operator, does it beg the question as to why not apply is everywhere and make a simple triple equals, make dot triple equals? I don't fully understand the question, but certainly if you're wanting to check if first equals last, it's really useful that does user-defined equality checks. So that's really useful. Having a reference equal, you could do that. We do have reference equals first, last. I find that when not checking for null, I almost never want to check for reference equality. So now that there's a better way of checking for null reference or not null reference, I think my use case for reference equals is vanishingly small. However, it looks like that wasn't my interpretation of the question wasn't the right one. Does dot become redundant to question mark dot? No, it's still really useful to have the two. So there can be plenty of times where you know something can legitimately be null and you want to keep going if it's not null. But using just dot makes sense if you really would like it to go bang. Aside from anything else, the return type or the expression type is now nullable of int. So in order, if I can't write int x equals middle dot length, and often I would really want that. And if I'm then going to write dot value, then I might as well do that and get the null reference exception instead of the invalid operation exception. And if I do want to provide a different default value, in that case, yes, it makes sense to use that. As for, does question mark dot internally invoke the equality operator, or does it now use pattern match? That doesn't, this isn't trying to be awkward. That doesn't make sense as a question because pattern match is a source code concern, whereas question mark dot compiles to some IL and there's no concept of IL at pattern matching in terms of pattern matching, but it doesn't, question mark dot would never call a custom equality operator. It always just checks for a null reference thing. Okay. As James writes, can't middle dot has value be used? No, it can't. That's a good question. And the reason, so I can write that and it will give me an error. There is no has value thing on string. And this is not a nullable. This is middle is not nullable of string. Okay, it is, as far as the IL is concerned, as far as the CLR is concerned, it's just string. That's why I can use .length on it. I don't have to go via something else. And nullable of T is still restricted to T being a struct. So nullable value types have a different representation in IL to non-nullable value types, whereas nullable reference types, they're mostly a compile time concern. Okay, if you've used Java at all, then it's a little bit like Java generics are mostly a compile time thing, still really useful, but mostly a compile time thing. The runtime doesn't know about things. It's very similar for nullable reference types, and also for the element names in value tuples. You know, if I've got var x equals int y, int z, or other. I think that will work. Yes. So int a, int b. I've just realized that's not even using tuples. I'll confess this now, I get very confused between tuples and pattern deconstruction. This is actually declaring local variables of y, z, a, and b. I won't go into the tuple literal syntax now, but value tuples where they've got different names, they're still the same type because the names are only really present at compile time, apart from in terms of some attributes. And that's really, really similar to nullable reference types. Okay, hopefully that's all the questions for now, but do keep them coming. This is always good. So what I wanted to demonstrate is if middle is object, then we're going to put first, last, and middle. And if middle isn't an object, then we'll just put first and last. And I still need to put first.length, last.length. Oh, there was one other, not quite question, but comment, which was really useful. Craig said, liking the console app more than anything. Well, the good news, Craig, is you can use it without having to rewrite anything yourself because it's jonskeet.demoUtil. It's not exactly documented because it's kind of primarily for me, but it is just a public NuGet package, and you can see what I do elsewhere. Yeah. Okay. And it used to be that you had to have a program file that would invoke stuff, and I added some MS Build magic to automatically call into the thing that asks you for stuff. So you just need to write a bunch of types with a main method. Okay, back to our demo. So I'm going to run this, and it should print first, last, and middle for me, and first and last for Miguel. I would stress we're still in the basic demo, and it's nearly 7:30. I've done C#8 talks for like 3 hours before now and not run out of material. So now it's doing first, last, and middle, and then just first and last. But there's something interesting happening here. Previously, middle was declared as non-nullable, but we got a warning when we tried to dereference it. Now it's declared as nullable, but we're dereferencing it with no warning. That feels like it's kind of the wrong way round. So that's a bit odd. Well, this goes back to what I was saying before, that the compiler knows that if it's gone through this bit, then middle definitely isn't null. So it's safe to dereference it. And when I say definitely, in this particular case, it's correct, but there can be times when it's not. Let's give an example of that. So let's get rid of these local variables, and let's do person.middle is object, and then we can do first name.length, person.lastname.length, person.middle name. And when I first saw this, I was freaked, and I'm still slightly freaked. Okay, and that compiles with no warnings at all. And Piran, I will, apologies if I mispronounced your name, I will come back to your question in a minute. So it compiles, it runs, is all good. So how does that work? We're now using a property. And we're used to the compiler doing some reasoning about local variables. So I've previously referred to the sort of extra information that the compiler keeps about variables in terms of nullity as being a little bit like whether it's definitely assigned or not. So, you know, I can do int x and then console.writeLine x will fail because it isn't definitely assigned. There is a little red squiggle there. If I do even an if true, x is 0, then the compiler knows, well, if true is always going to happen, so it's fine to print that. There are some ways that you can fool this, but we won't go into that. But it's keeping some extra information about the variable, whether or not it's definitely assigned at any particular point in time. And the compiler's doing the same thing for nullability, but not just for local variables now, it's also doing it for properties. Now, let me demonstrate, before I come back to the constructor question, let me demonstrate why that is at least somewhat dubious. Here is a very odd property. Sometimes it returns null and sometimes it doesn't. Now look at this code here. This checks the name property, sees whether or not it's null. If it's not null, then it prints the length of it. But it does that by evaluating the property a second time. Now, normally, most of the time, this code will be absolutely fine. But it is just possible if you call it just coming up to the start of a minute, that when you evaluate if name is object, it says, oh, well, the second property is currently 59. So I will return not null. Then the clock ticks and we end up calling name.length. And then it says, oh, well, now we're on the minute. So second is 0. We will return null and this will go bang. So the evaluation, the reckoning that the compiler does about when something is going to be not null is not bulletproof and doesn't try to be absolutely bulletproof. There are other examples if you're playing along at home. Changing field is a particularly weird, evil thing to do. And again, you will confuse the compiler. You can do the same thing with in parameters. There are various ways that you can fool the compiler, but most of the time it will do the right thing. And frankly, if you have properties as weird as this, then you deserve all you get. What's more likely is that you've actually got a property that is being changed from one thread and you don't spot the fact that it's, effectively you've got not thread safe code. And this isn't introducing a new bug into that. It's just, hey, having unrestrained modification of shared state is generally a bad idea. Let's not do that. So it's not introducing a bug in this case. It doesn't happen to protect you from that thread safety bug. And the reason for having this, you might think, well, why don't they just make it bulletproof? And the reason is there are all kinds of places where it would just be really painful if it did. So this is the nullable reference type feature is a prime example of the C# team valuing a pragmatic approach. They have tried to protect you as much as they can without getting in your way more than they need to. That won't always be exactly as we might want it to be, but most of the time it is. Right, okay, finally back to Paran's question of could the person constructor be first name, last name, and middle name equals null? So the suggested one here is having a default for null like that, and that won't compile because string is non-nullable, but you can absolutely make it nullable, and then we could write Miguel de Casa there. So this is just perfectly regular optional parameters, and that's all fine. So hopefully that answers that question. Okay, I never know the right place to go after this basic demo. There are generic constraints. So we have a new constraint of not null for T. So it's fine to do not null of int and not null of string, but not null of int question mark isn't valid, even though it's only a warning. And likewise, not null of string question mark. So it's a sort of somewhat advisory thing. You can have class question mark as a constraint. So that says, hey, it might be nullable. Doesn't mean that it definitely is, but it might be. The normal where T colon class constraint says, no, this has to be nullable. So you can't do not nullable ref of string question mark. Okay. Generics are basically a pain everywhere. So here's a generic type that it seems kind of reasonable. So T is not nullable. We want to have a constructor that accepts a non-null thing, but we want to have a default constructor with T question mark. If we don't have that, Joe, I think I think this was meant to be T. Haha. Yeah, I've left in a change from an earlier version. So it looks like, in fact, this my comment here has been fixed since I wrote it, so I'm just going to get rid of it. Interestingly, default of T is no longer T. Yeah, default of any particular type should be of that type. Well, it isn't anymore. Default of string is string question mark because it's null. We know absolutely that it will be null. Instead, we need to use the Dammit operator. And this is a good time to introduce the Dammit operator. Now, in this particular case, this is definitely violating things. So value will be null. If we get rid of that, that's now far more reasonable. You have to provide a non-null value, and it will return a non-null value later on. However, there are some times where if we've got some more cunning property, you just want to be able to have, or maybe this is a field, there are times where you want to be able to tell the compiler, I know better than you. And that's what this Dammit operator is for. It's also sometimes known as the null forgiving operator. But much as Roslyn is always known as Roslyn instead of the Microsoft compiler framework or whatever, I want to keep everyone calling this the Dammit operator forever, until Microsoft feel that actually they need to even document it as sometimes called the Dammit operator, which means they get all kinds of people involved who think that dammit is kind of swearing, and it's interesting. But the point of this is, oh, it's not null, damn it. And sometimes you know that something isn't null. Think of it as a little bit like casting. And yes, David, you did hear it right. It is the Dammit operator, and that is my spelling of it as well, double M in the middle. I quite like the gosh darn operator. That's quite fun. Yeah, feel free to spread it as the gosh darn operator for more polite people. But usually there are two uses that I want to highlight as good uses of the Dammit operator. This isn't a good use because this is telling the compiler just shut up while you're doing something wrong. But there are times where you really want to do this. There's one that is easy to demo and comes back to basic demo and a little to do. And there's another that's harder to demo. I can refer you to the NodeTime source code, in fact, I think if you look for to do brackets nullable, you'll find a few examples of this. I've used that as a convention for, hey, stuff that that I wish worked and didn't. But sometimes you absolutely know that something will not be null, and it's just much easier to use the Dammit operator than to say, hey, if it's null, I would like you to go bang. If we're wanting it to go bang, if we want to say, so here's an example, string name equals type of basic demo dot full name. Now, if I'm right about, oh, look, name may be null here. Well, do you know, I'm pretty sure that type.fullName is not going to return null. So if I want to get rid of the warning here, just use the Dammit operator and probably note we're pretty sure that full name won't be null here. It's possible that for some other types, full name really will be null if it's some weird dynamically generated type. I don't know when full name would be null, but the compiler believes it is. There are other things that won't be null, but that might be. So that's one example. Basically, you know better than the compiler. And while you could do that and say, if name is null, throw new null reference or invalid operation exception. My life makes no sense. You could do that, but that's an awfully long-winded bit of code for, do you know what, I'm just sure that it won't be null, whereas that isn't. And if you're wrong about that, then you'll get a null reference exception later on, probably in the wrong place, but that's fine. Great question from Ewan, and one from Nicholas that I will come up to in a minute. Does the Dammit operator throw if the variable is null? No, it does not. And that's really, really important. And in fact, I will demonstrate that with a good use of it for test purposes. And then Nicholas, I promise I will come back to you. So let's create a person test. Now I happen to have, normally I wouldn't write tests in the same project as the class itself. But in fact, I'm feeling so cavalier, I'll just do it right here. So let's write a test. It's n unit, not x unit. So it's test rather than fact. And first name must not be null. Come on. I did check earlier on that we have, right, there we go. Everything is that much slower when running with Zoom. Okay, so we want to say assert.throws argument null exception if we try to construct a new person null last middle. Okay, and right. So we get a warning for this, which is entirely reasonable. It's not meant to be null. Do you know what? I know it's not meant to be null. That's why I'm asserting it will throw an exception. We'll come back to whether it should throw an exception in a minute. It should. But you know, this test is a perfect test. It's saying what I want to happen, and then we do, you know, the same for last, but we'd have a test for middle saying, hey, it can be null. So how do I get this compiler warning to shut up? I could say I don't care about nullable reference types within this test, but that's really throwing the baby out with the bathwater, because I might have other things that are incorrect in this test. It's not so bad when I've got one line of code, but I don't want to be disabling this. I want to be able to rely on this. What I want to say is, just let me do it, damn it. Dammit operator. So we're saying, please treat this null value as if it's not null. You know, trust me, this won't be null. When, Do you know what? That null reference really, really will be null. And this does not throw an exception. And that's really important. And one reason it's important, this test should, and I believe will, fail. Dum, dum, dum. Admittedly, running the test may take longer than we have. Oh, it was so close. There we go, run test. And while it's doing that, this is going to fail because, hey, there's nothing in here that is going to throw an exception. What I'm going to show you will hopefully become pointless in the end. Oh, maybe it's got to be a public class. Maybe that's the problem. I'm not sure. I hope so. That would make sense. Yeah, it looks like that's better. No, it's still not finding it. I think it's probably I haven't got the NUnit VS test SDK or whatever. So we'll just ignore that. Believe me, that would fail. What we want to do is say, well, there are some options here. We can do this. And boy, is that a bit of a mouthful. But that would do the trick. If first name is null, then we'll throw. Or we can do preconditions dot check not null first name. And that is a method that I've got, and I've written this many, many, many times, which is pretty much as I showed the longer version. And in fact, this version doesn't have the name part. Normally, I would have string name and then name. Okay, and I would use name of. As of C#9, there will be a way of doing this where I don't need to pass the name via name of. So currently I would do this like that, and that's still quite long-winded. So C#9 will definitely allow me to get rid of this part using member expression or caller expression info, I believe. I'm hoping it might also allow me to get rid of all of this and just write that instead, or maybe that. But something on the parameter saying, please compiler, check me. Now, I said I would come back to why we want to do this, and now the test would pass, but I still want to have the Dammit operator. So this using the Dammit operator in tests is one reason to do it. The other is for things like, oh, I got rid of it, but the type.fullname, I'm really confident that it's not null, just go away. But importantly, unlike a cast, although it's telling the compiler to shut up, it does not change the IL that's emitted at all. So if it's null and you're dereferencing, you get a null reference exception. I don't get a null reference exception here just because it says, hey, I'm just going to pass null. And this comes to why we need to validate arguments. Okay, if someone passes in null to here, either because they're doing it directly and using the Dammit operator, or because they haven't got nullable reference types turned on, or because they're not even using C#8, so can't turn on nullable reference types, or because they're calling it with reflection, or whatever it is, we would like to find out the problem there immediately. We want a stack trace that says, you called the constructor with an invalid value. We don't want to get it miles later after we've already saved something to the database and something happens to dereference first name for some other reason. Okay, this is a constraint that we should validate, and the compiler does not do it automatically. Remember what I said before about the IL is generated exactly as it is before. So if your code would have gone bang before, it will go bang now. If it wouldn't have gone bang before, then it won't go bang now, even if you're assigning something a null value and you've said it shouldn't be, the compiler doesn't insert any checks for you. If they introduce the syntax like that or like that, that will be a C#9 feature that will introduce a check, and that will be the first time that it really does change things. I see there are some comments. Test fixture is not necessarily necessary in NUnit or XUnit. Yeah, shouldn't need any of that. Still don't know exactly why it's not finding it, but that's fine. Now, right, Nicholas had a question of, what about if person.middlename ? Is int middle length? Middle length? Yes, that would absolutely work. Dot length is int middle length. And now, interestingly, the compiler also knows that this means that person.middlename is not null, because the only way that length could be a non-null integer is if middle name is not null. But obviously you would normally at that point use middle length. So yes, that all works fine. And that's just C#7. So that would have been valid code in C#7. Nothing's been taken away. One final bit, I'm already over time for, people keep talking about the test attribute. You really don't need it in NUnit. You haven't for quite a long time. So yes, I could do test fixture, but I don't believe that will, it's possible that will suddenly light up testing, but I don't think so. I think it's because in the project, I have NUnit as a dependency. I don't have Microsoft.test SDK or whatever it's called. And no, it's still not finding it. Okay, so I'm already over time for nullable reference types, but I do want to show you one extra thing in a tiny amount of detail. Just for, there are cases where what I've shown you isn't enough. So I've shown you new syntax of adding question mark after the name of a type and adding exclamation mark for the Dammit operator. Those are the only two new bits of syntax, but there are some new attributes. Now, all of the nullableness is baked into the assembly via new attributes. And so if I ran ILDASM and looked at person, then all three of these would have the nullable attribute with different arguments to say, hey, this is definitely not meant to be null, or this might be null. And the presence of the attribute in the first place says, hey, this was compiled with something that knew about nullability. But sometimes that's not enough, and there are some extra attributes as well. And sorry, wrong thing. It was conditional return. So think about dictionary. So dictionary.tryGetValue has an out parameter. And if tryGetValue returns false, then you know it's going to be, the value will be null. But if this is a dictionary of, say, bool to string, then if tryGetValue returns true, then it really should be non-null. So without this, it should be, it looks like that should be fine, even though we know it won't be, because we're returning, or we're setting the out parameter to be a null reference, because that's what dictionary says to do. Obviously, this code isn't in dictionary. I'm saying imagine that this was in dictionary. So we want a warning here. And if we put the maybe null when, that reintroduces the warning. So that's telling the compiler, hey, I know the type of the out parameter is just string, but hey, if the method returns false, then it may well be null anyway. The sort of opposite is string.is null or empty, where if the method returns false, so if it's definitely not null or empty, then the compiler should know, hey, I may not have known whether or not it was null when I passed it to the method, but now I should be able to rely on it not being null or empty. So exactly here. So if it's null or empty, fine. Otherwise, we should be able to use text.length without a warning. And we can do purely because of this attribute, this not null when. There are a bunch of those attributes. I don't have nearly enough time to go into detail about them, but they are there, they're documented. If you search for any of them, you'll find the rest and some documentation around them. You won't need them terribly often, but when you do, they're absolutely invaluable. There are some things that we still can't necessarily propagate and say, well, that's not null if some complicated conditions, but they're a really good start. I mentioned I would talk about how to enable this, and that is within the project file. So to turn on nullable reference types, you have to be targeting C# 8 to start with, and then you just do nullable enable. I believe at one point there was talk about turning it on by default for Net Core App 3.1, but not for earlier versions. I think that all went by the wayside, and it always has to be there. It may be that file new project will put that in there for you, but I think it always has to be explicitly in the project file, partly because it's so new for many developers still. Okay, that's all we've realistically got time for on nullable reference types. I will take a 5-minute or possibly less break to answer some more questions, and feel free to unmute and just kind of give reactions, have a brief chat just while I go a bit. And I will stop screen sharing for a minute as well, just because it's nice to have faces for a bit.
So what I love about this then, does this mean that we can now finally win an argument with the computer?
No.
And now, after a flurry of earlier questions, there are none.
Jon, quick question on out parameters. Wouldn't it
I should say this is all really quick, and I normally, hey Fran, I generally take more than an hour and a half to try to get through stuff. There's just so much in C# 8. I would love to be able to say, hey, just read C# in depth 5th edition, but I haven't even started writing that yet. At some point, in about 3 years' time, you may be able to read about it. However, there is good documentation on docs.microsoft.com, so that's probably the first place to go. Hopefully, here, user group sessions aren't really good at teaching, despite what some people may think. What they're good at is saying, hey, that's something I need to investigate further, and maybe sort of some specific points. Yeah, I'm seeing some agreement there. You can't learn. This is a really heavy topic. There's loads of stuff in generics. Yeah, thank you, Fran. There's loads of stuff about generics in nullable reference types that is really, really painful and tricky to get your head around. You're not going to get it in 10 hours of me talking. What you want is try it. When things go wrong, do some research and you'll get there. Okay, I have some questions. Okay, Ewan said, I thought I knew C# 8, but really I just had a question mark everywhere. Yeah, that's kind of interesting. There will be some projects where that's absolutely what you should do, because maybe everything can be null, and that's fine. I found that in Node time, some things could be null, some things couldn't be null. I only found one actual bug by doing this all with Node time, which was I have one bit of code that thinks that timezoneinfo.id can be null, because sometimes it can under mono, and most of the time it can't. And so I was inconsistent about that, and I've now fixed the inconsistency. Other questions? Does the Dammit operator now mean that we can finally start winning arguments with our code? I decline to answer that one. Making a generic class where T can be value or ref type. How do I return nullable? You don't. Welcome to the joy of nullable reference types and generics. Yeah, they just don't go well together. And if you want to know why, think about what it would look like from the IL perspective. Nullable of T, when T is guaranteed to be a value type, there is a struct called nullable of T, and that's what your return type would be. Whereas if it's a reference type, your return type in the IL is just T. They are different. One has a wrapper, this nullable wrapper, and the other doesn't. They are completely different representations. I suspect if C# were being designed from scratch today with a completely different runtime that we could go back to the drawing board for everything, I think there would be a way of doing it. Probably. That is not the case. We have to live with what we've got. And the C# team have done a really good job with the heavy constraints that they have. Is that why Swift completely neutered their type system? I don't know enough about Swift to comment at all. I work in a team of 8 devs. Any tips on how we start using new C# 8 features in a controlled way, or should we just get stuck in? That's a great question. So I would say you can use most C# 8 features, the ones that I will be showing in the remaining 25 minutes because I've overrun massively. And I really do need to stop at 8:30 because I need to have my dinner before a later meeting. You can use most of them without turning on nullable reference types, and I do that all the time, and that's great. However, when you want to do nullable reference types, the advice I have given for quite a long time is to tell management you will not have working code, so no new releases, no patches, no new features for some number of weeks. And ideally, you do a bit of research before that to say how many weeks that's going to be. After that, the benefit is we will be able to release things quicker because we will understand our code better. I know that's a hard sell. Okay, really telling management we won't be able to release anything. And to be clear, you could release patches. Obviously, you'll have a branch where you can do all that, branch off the previous release and you can do work. However, you should expect stuff to be in pieces for a while. You then get some architecture diagram and think of the leaf projects first. Those are the ones you want to annotate with nullability everywhere. Get all of those working. Then do the things that depend on them. Then the things that depend on those. And every time you add some more things that depend on other things, you'll find some mistakes that you made the first time round. So you fix those up and then everything should start propagating, but you definitely want to start at the leaf projects. So it's definitely doable. You could potentially do just one leaf project, make that nullable aware, and the other project that doesn't have nullability enabled will just say, oh, I'm calling into some stuff that has things I don't understand. That's fine. I'll just keep not understanding them. So you could do it a project at a time and keep releasing stuff as it is. Just don't worry that when you turn it on, the world will go to pot. Really, it will feel like 2020 all over again. But I think it's worth doing in general. Next, so we tried to add Nullable into a project that was started with C#7 and it was a bit of a pain, so we ran away. That's entirely reasonable as well. It is a bit of a pain, and it takes a bit of a while to get used to some new patterns as well. You might have another try later on. Stefan said, not null when attribute and others are available in .NET Standard 2.1. What's the best approach for libraries also targeting .NET Standard 2? The best approach is to add those attributes in yourself. You can absolutely do that. I've done it myself in various things. The compiler just wants the attributes to be there and in the right namespace. So you can put them into your own project. I would make them internal at that point so they don't confuse things. And if you're multi-targeting, then do a #ifdef so that it only tries to introduce them if you're targeting something that doesn't have them. But then the compiler will work with them perfectly easily. Callum asked, is there anything about C# I would change? Yep, quite a bit. That's a whole different talk. I might do that as a talk, a standalone talk at some point. Will you be able to release code quicker immediately? It sounds like that too would take time. You'll be 1% quicker immediately. So as soon as everything is attributed correctly, you will start being able to develop quicker because you won't need to check, oh, does the documentation say that will be null or not? So you do get benefits immediately. I don't expect those benefits to massively increase over time, but it's a steady drip that you don't have to do anymore. Okay. I'm going to take that as the end of Nullable reference types. Feel free to drop me emails with further questions, or ask on Stack Overflow would actually be better, and then email me with a reference to the question. I'm going to share my screen again and also open the door behind me and the window in front of me because it is roasting in here now. In fact, it's not much hotter than it was before, but I seem to generate more heat when I'm talking. It could just be all the hot air. I'm going to stop sharing the results of the poll because we've all seen, yeah, most of you aren't using C# 8 yet, which is interesting. Hopefully, the second part, even if null reference types, I understand, are really quite scary, that's fine. I hope I'll be able to convince you that some of the stuff in C# 8 for other features is really sufficiently yummy that you'll want to get onto it immediately. Let's go and get onto the yummy part first. Which is patterns and switch expressions in particular. This is my absolute favorite feature, I think, of C# 8. It's the one I use all the time. Breathe. Okay, I have in this file a bunch of Fibonacci implementations. I'm a big fan of Fibonacci. It's a really interesting code problem. Here's a recursive form. Here's an also recursive form that does a check and then uses a switch statement. Here's still using a switch statement, but it's got the check built into the default case. Here's another one using, sorry, no, this is the first type using a switch expression. So concentrate on fib3 and fib4a. This is valid C#7. What do we need to do to turn this into a switch expression? A switch expression is just like a switch statement, but you can use it anywhere that you can use an expression, including as an expression body member, as we can see here. So the body of fib4 is just an expression. That's really, really, really nice. But it looks kind of different. So firstly, instead of switch n, we have n switch, where n, I think you probably could put it in brackets, but they're not brackets that are part of the syntax itself. They're redundant here. So it starts n switch, and then what we have in the braces is a list of case arms. Okay, and just like all other lists, like parameter lists and declaration lists and things, these are now comma separated. So here, this was the semicolon belongs to the end of a statement. Here, the comma is just something between multiple elements in the list. We don't have case. Instead, we have the fat arrow. I still want a better name than fat arrow that doesn't suggest body shaming and stuff. Note that this is not a lambda expression. It hasn't been a lambda expression, for ages. Lambda expressions were just the first syntax that the first semantic, the first operator that used fat arrow as the syntax within it. But just as it's not a lambda expression here, it's not a lambda expression here either. It's just saying if the pattern on the left matches, then the result of the expression is the right-hand side. And we don't need return anymore. We haven't got case. We haven't got default. Instead, the way of expressing default in a switch expression is just, hey, it matches anything. The underscore is the discard pattern, and it will match anything. So fib4a and fib4b are the same, except it's using an expression body member. And then fib5 this is probably my favorite implementation of the recursive form. So we can say, okay, well, first we will check whether it's less than 0. And if so, throw an argument out of range exception. Otherwise, is it 0? Is it 1? No? Okay, I will recurse. And I like this the most because it's got a clear precondition, then the sort of boundary cases, then the recursive case. If you were to write down the definition of Fibonacci, it would be pretty close to this. So that's kind of it for switch expressions, other than there are a couple of limitations if we wanted to say case 2 should return 1 as well. You can do that. There's no equivalent of multiple cases matching the same expression in switch expressions, and that's something that may be addressed in pattern matching. It's possible that this will be valid C#9. I don't know. We'll see. Oh, it looks like it probably will be, given that the compiler is now saying the feature or pattern is currently in preview and unsupported. To use preview language features, use the preview language version. So this is already turning into a C#9 talk. But may not happen. We'll see. So that's one caveat. The other is it really does have to evaluate to an expression. It has to be complete, exhaustive. If it's not, you do get a warning. So if I get rid of the default in this case, we will get a warning saying the switch expression does not handle all possible values of its input type. It is not exhaustive. For example, the pattern 2 is not covered, and it's absolutely right. It's only a warning. So if you try to run it at this point, in fact, 5 was fine. So startup project. I believe this will throw an invalid operation exception, which is entirely reasonable. So you may well want to suppress this warning in places where where the only reason why it wouldn't match anything is if you've got a bug and you want to throw invalid operation exception anyway, because that's the right thing to do. So in fact, it throws a switch expression exception. So I think it's fine for that to be thrown, and in cases where you've deliberately done that, and I've got a few of those in Noda time, I would just say suppress just around that. I'd probably put it around the whole switch expression instead, but that's fine by me. And I put a comment saying, hey, if this doesn't match, then that means that this invariant has been broken. And aside from anything else, if you're using code coverage, that stops you from having to have a bit that you can't cover, because the only reason you would ever be able to cover to get into that value was if you had a bug. And it's just craft. There are a few questions I see. Right. Lots. Goes to or produces or I'm not sure about implies, but produces or goes to are fine. Arrow function or arrow expressions. Yeah, those. Yeah. Instead of fat arrow makes sense. Ewan asks, does order matter? Yes, it does. And sometimes it matters in a way that the compiler can spot. So suppose we go back to switch expressions. Suppose we take this and put the default above everything else. So that matches everything. And now these three couldn't possibly match because it will already have taken the first one. But there are cases where two things will match and the compiler may not be aware of that, but it evaluates them in order. Any performance benefits to doing the switch one way or another? I expect it to compile down to the same IL. Not sure. Ewan doesn't like switch. Any technical advantage over if blocks? Well, I think it's much more readable myself. I can see here that everything is covered. I can read that, in that case, it will do one thing, that will do another, that will do another. The same code in here feels much more long-winded, and it's just not as syntactically clear. In this case, I'll do that. These could be entirely different conditions, and it wouldn't be terribly obvious. It becomes even more important with property matching, which is the next feature I'll talk about. I'm frankly not going to get to everything today. I will talk about this really, really briefly. But here are things. Here's a switch expression where an item can be a work of art or a weapon, and we'll match against what type it is, and then do a recursive match to say, okay, if it's a weapon that has a damage of 0, we will say that it's harmless. If it's a weapon with a damage of D, and then we'll check that D is greater than 500, we'll say, oh, it's heavy. And we've captured that it's a weapon called W. Otherwise, it's lightweight, and we've captured that it only does D damage. Finally, if it's an artwork, we'll match the creation date using a deconstruction pattern that captures the year in which it was created, and doesn't care about, so underscore for discard, yeah, match anything. But we'll capture the year to say it was created in this year. Let's just, for the sake of fun, get fact with if item. Now we can say if we can use this pattern here as well. So if item is weapon damage :0. But you might decide this really is best when in a switch expression, in my view, harmless, and we could do all of that. Obviously, we can say if item is weapon W and W.damage is 0. But I think by the time you've done all of these bits, it will be significantly more long-winded. And once you get used to it, it does take a little bit of time to get used to this, but once you're used to it, this pattern matching can be really nice. In some cases, there are plenty of cases where you won't use this in a whole project, and then you'll do a project where it makes perfect sense. I find with reflection, it can make a big difference. If you want to say, oh, do one thing if it's generic and it's got one type parameter in this particular way, otherwise do something else. It's particularly useful for inheritance, and you want to map different things. I think it helps also if you're used to functional programming, and F# and Haskell do a lot of this kind of pattern matching. Matteo asked about memoization for C# Fibonacci. No, there's no decorator to do that. Nicola said switch expressions for polymorphism. I guess you're just talking about, yeah, this does polymorphism effectively. And Tony noted that it's similar to match in Rust. Okay, I've got 10 minutes left. I'm going to zoom through things as quickly as I can. So async has some more stuff. There is async disposable, and now you can await using, which will dispose of things asynchronously. But I'm done. There is async enumerable and async enumerator, and you can now create things with yield return that do this. This has been a source of massive pain to me, because this is not the same async enumerable and async enumerator that was in system.interactive.async in a previous version, and it's not compatible with it. And if you're using the old version of RX, basically you need to upgrade at some point. It's a breaking change. Pick when you do your breaking change. It's annoying. It's really, really annoying. And I've just seen Tony Gerling is here, who I believe I used to somewhat tangentially work with. So nice to see you, Tony. Very, very, very long time ago. Okay, so that's what's happened async-wise. Using statements, ignore the duck disposable bit, but this can be really useful. You can have using statements without the braces. So this is exactly equivalent to putting it in braces around the whole of the scope of the variable. Okay, that doesn't look too much, but what if you've got, I I would bring up another solution, but it would take too long. But I have something like using var server equals create server. This is in test code. Using var client equals server.create client. Using var response equals await client dot get async something, and then I do some stuff. If that were all expanded out with brackets as well, then by the time you've actually got to code, you're triply nested and it's really annoying. I'll get rid of the, so real code. And that's just now looking at that, it's really annoying. It's not so bad. I don't habitually use this yet. And if I've only got one using statement, I'll often just put it in a block. If you don't want the using statement to last until the end of the scope of the variable you're declaring, just use what you've got already. It's fine. It's only a convenience thing. Okay. Next feature, indexes and ranges, because they're quite fun. So there are two new types called index and range. Index is a non-negative value integer and a from start or from end. And these are BCL types now, and you can create them using integers. In fact, I've got a whole, I'm just in the wrong file for it. So index 1, so index dot value will be 1, and index dot from end is from end will be false. If I do index from end equals caret 3 or caret 5, then value would be 5 and is from end would be true. And you can use that with indexes. And these days, the compiler will even generate calls to you if you're trying to use an index value into something that implements ilist of t, but doesn't know about index at all. It will say, oh, I know how to get to a particular index from the end. Now, big question here is, what do we think text of index should be? Should it print C or E? Now, I'll say that if we did 0, that would print the C, and 1 would print the O. So you might expect it to say, okay, well, hat of 0 returns 0 from the end, hat of 1 returns 1 from the end. In fact, and I'm just going to double check this because, as I say, it's been a little while. If I run this, I believe it will print E to start with. And I will then explain why that is actually, even though it sounds like it's inconsistent, it's the right call. Yes, it prints E. Think of it not as saying this is 0 from the start, but my cursor is placed now 0 from the start. And when you use the indexer, it returns what's at your cursor. If I move it on 1, my cursor is now 1 from the start, and the thing at the cursor is the O. Fine. If I'm 0 from the end, the thing at my cursor is the close quotes. If I'm 1 from the end, the thing at the cursor is the E. This makes a lot more sense as well when you think about ranges. So a range is just a pair of indexes. Could be 2 from the start, 2 indexes that are from the start, 2 that are from the end. Here's one that starts, 1 from the start as far as 2 from the end. But this is always exclusive. So if I do caret 0 means to the very end, because I'm now saying it's from cursor 1 in to cursor 0 from the end. So that range would be hello world. If I do it _2, so 0 from the end, 1 from the end, 2 from the end, this is now hello were. And the nice thing about ranges is there's a consistent way of working against arrays and strings and spans. And with spans, you get the benefit that they slice instead of, this will create a copy of the substring. And likewise, if you do arrays, it will create a copy of that bit of the array. So you don't want to use that terribly often from a performance perspective. Whereas when you're using spans, which are a whole other topic, you end up getting slices, and they are just references to the same bit of memory. So you can take one long string, create all kinds of slices of bits of them when you're parsing, and it doesn't need to create any copies of memory, which is great. Tiniest feature ever. It's self-explanatory, read my screen. I don't know which of these was valid. I don't care anymore, because both of them now are. So it can be a verbatim interpolated string literal or an interpolated verbatim string literal. They're both valid under C#8. Okay, one more, and there are, I will show you, I haven't got time to explain it, but I will show you default interface methods. So this does not look like any interface that you have seen before in C#, because, hey, we've got a method with an implementation. That's a bit weird. The idea is this allows you to evolve interfaces. One of the ideas behind this is this allows you to evolve interfaces, adding extra methods without breaking existing implementations. Now, it would be valid to say, something like void new member, throw new not implemented exception. Okay, that's often absolutely fine if you want to make sure that the interfaces will still compile, but this is really for the sake of, you're providing the only implementation of this interface, and any other implementation is going to be in test code, and that won't be calling new member anyway, and it's fine if something does call new member, it's fine for it to throw the exception. The other case is where you can provide a default implementation and it will work, but maybe it could be more efficiently done another way. And implementations of the interface can always effectively override, but provide their own implementation. That is all I have time for tonight. That is a very, very, very swift way through C#8. I've just noticed one last comment in the chat. I think of index as ordinal access. 1 equals start equals i0 plus 1, and _1 is length minus 1. Yep, that's fine. Yes, it definitely works that way around. Does default interface methods make abstract classes less relevant? No. Or, well, less relevant, yes. Irrelevant, no, because you still can't declare a field. String name will not compile, I hope. Yeah. So if you can genuinely provide most of a common implementation in an abstract class, that will often involve state, and you can't introduce state in interfaces. So several of the places where I've used abstract classes, I would still do so. If I have an abstract class which just consists of abstract methods, which is entirely reasonable, in that case, yes, you could now use an interface. Okay, that's all I have time for, and I really do need to go and have dinner. But thank you very much, everyone, for bearing with me kind of rambling. I hope you enjoyed it, and I hope you enjoy C#8. It's great fun, and let's start looking forward to C#9.
Cool. Thanks, John. I think I speak on behalf of everyone, really, that we've all taken something away from this tonight. So, yeah, really appreciate your time. Just to let everyone know as well, I believe we topped out at about 217 people tonight, which is a really solid number. So thanks, everyone, for getting involved. Just to give you a bit of information as well, the recordings will be released next week in case you'd like to rewatch the whole talk or you missed anything. It'll also be posted on our LinkedIn page as well, and we'll send an email around to all of you with a short survey. So we'd really appreciate it if you could just fill that out for us, because feedback's always greatly appreciated. I'm not too sure if this has gone live on any of our socials yet, but just to give you a bit of a heads up, we've got the next couple of meetups booked in now for October and November, I believe. So we've got Martin Beebe, who works for AWS. He'll be giving a talk on developing with .NET Core on AWS. And the month afterwards, we have Kia Zhao. She's an Azure MVP and CTO at Capgemini. She'll be giving a talk on Azure AD B2C, application security made easy. And yeah, details for those will be released over the coming weeks, so keep your eyes peeled. And as always, if you have any speaker or topic suggestions, just let us know. And yeah, other than that, thanks very much for coming along tonight, and have a good evening.